All right, because we ran out of time, I need to go over section 14.6 with you this way. So you want to start on the slide, law versus theory, okay? For the last few class periods, we've been looking at writing rate laws, how to understand the relationship between concentration and time, looking at them when they're graphed, okay? But we've been looking at reactions overall from start to finish, and we haven't been thinking about, like, so what is the process that actually occurs, especially when there's more than like one or two different types of molecules at play. All right, so 14.6 is about reaction mechanisms, which breaks the balanced equation down a little bit further to say, like, okay, which substance is colliding with which other substance, so that you can understand, like, which collision process is really affecting the rate and all of that, okay? So we're going to look at this today, and I'll try to break it down for you, all right? First of all, be aware that a reaction might occur exactly the way it looks in the balanced equation, or it might be a bunch of different steps that are sort of consolidated into the balanced equation, okay? If the reaction is actually a series of steps, each of those steps is referred to as an elementary reaction, and then all together they equal the entire overall reaction. Okay, there's a couple different ways that you might see an elementary reaction, okay? Just be aware of these different terms, all right? So unimolecular is exactly what it sounds like. It means that you have one molecule breaking down into the products, okay? So that probably means, like, it's a decomposition reaction, and that it breaks down in the products, okay? Bimolecular means you have two different molecules as reactants, okay? They can either be the same, so like you have two sodium molecules, for example, or maybe they're different, and you have a sodium molecule and a chlorine molecule. So they can both be bimolecular. It's a function of how many molecules do you have. If it's two of the same, then that would be A plus A. If it's two different ones, that would be A plus B. And you can see how it affects the rate law, okay? In elementary reactions, however many molecules you have determines your order. So if you have two A molecules reacting, that would make your order 2 for that elementary step. Okay, if you have A plus B, then you have the concentration of A times the concentration of B. That elementary step is also second order overall. It's just written differently. And then you have termolecular. Ter refers to 3. Same idea. You could have 3 A's. You could have 2 A's and a B, or 2 B's and an A. You could also have 3 different types of molecules all together, okay? So using the terms unimolecular, bimolecular, termolecular, it really just tells you how many molecules are involved in that part of the mechanism, in that elementary step, okay? Just a little note, termolecular equations are actually really rare, because if you think about it, that means that 3 molecules have to collide simultaneously in just the right way for the reaction to occur. They do happen. It's not that it never happens, but just be aware that it's pretty unusual. If they do occur, that elementary step is usually slower than other types of elementary steps, okay? Because most reaction mechanisms use unimolecular processes or bimolecular processes. Okay, so what we're going to do next is I'm going to have you look at a couple sample exercises in the book just so we're sure that we understand this, okay? So if you can, look at sample exercise 14.12. I will scan these pages in so that if you don't have good luck accessing the online textbook, you can at least look at them, okay? So page 594, sample exercise 12, all right? It says, it's been proposed that the conversion of ozone into O2 is a two-step mechanism, okay? Where you have ozone going to O2. I'm not going to write the states of matter just to save myself a little bit of time, okay? Here's the first step, and then the second elementary reaction is this, okay? All right. So the question here is, A, says describe the molecularity of each elementary reaction in this mechanism, okay? So let me turn this a little. All right. So this is reaction 1. This is reaction 2, okay? Looking at reaction 1, how many different molecules are involved as a reactant? Just ozone, which means there's one molecule, so that would be unimolecular, okay? Now look at reaction 2. How many different reactants are involved in reaction 2? There are 2 of them, so that would be bimolecular, okay? All right. It says write the equation for the overall reaction. So when you look at that, what you want to do, so basically when they say write the equation for the overall reaction, they mean actually write the, like basically the balanced equation is the way to think about it, okay? So they want you to write the balanced equation. Hold on, I'm going to pause. We'll come back.